Okay, today is Thursday. What we are going to be focused on again is acceleration. Just let's review some concepts on what acceleration is. So, acceleration is the rate of an object changing velocity. This can be a positive or a negative value. Remember, with the negative value, we typically call it deceleration. So think of acceleration. Positively is an object speeding up, so like a car driving faster. A deceleration, so the negative value is the car slowing down. Units are meters per second, or meters per second squared. So there's typically two different ways that we write that. So biggest thing is that without a change in velocity, we cannot have acceleration. So remember that change in velocity can be either negative or positive, but there does need to be a change. Today's learning target is I can mathematically solve for acceleration. So here are some of the variables that we'll be using today. A, remember, lowercase a specifically, is acceleration, and the units for that is meters per second squared. V is for velocity, which is meters per second. Okay, sometimes you'll see V with a subscript of 0. That stands for initial velocity. And then V with a subscript of F stands for final velocity. And then T is for time, which we measure in seconds. D is for distance, which we measure in meters. So here are some of the equations that we have already seen throughout the week in more one way or another way. So we have final velocity equals acceleration times time plus initial velocity. Distance equals 1/2 acceleration times time squared plus initial velocity times time. And then time equals final velocity minus initial velocity divided by acceleration, this is another way of writing it. So we'll talk more about these equations later. It's okay if you don't quite understand them yet. We'll get more into that. The big one that we haven't seen and the one that we are going to use today is acceleration equals final velocity minus initial velocity divided by time. So remember, there are two ways that we can write it. So we can write it like this, or we can write it like this. Remember your order of operations. So with your order of operations, remember that we work with what is in the parentheses first. So even though there are no parentheses around this spot, we would want to do the subtraction before we do the division. So again, do what is in the parentheses. So do final velocity minus initial velocity before you divide it by time. So here's the process for solving the problems. First, you need to identify the knowns and the unknowns, find the equation to give you the unknowns from the knowns, and then plug in the numbers into the equation. And then, of course, do the math. So here is our example number 1. A car starts at rest and accelerates to a final velocity of 20 meters per second in a time of 5 seconds. What is the car's acceleration? So again, we need to identify, step 1, identify our knowns and our unknowns. So our knowns for this is final velocity specifically, okay? So final velocity is 20 meters per second. Time is 5 seconds. So that means our initial velocity, remember, is our starting point. So we started at 0 meters per second. Typically, you tend to start at things, so distance and velocity, at 0 unless indicated differently, okay? And then our unknown is acceleration, which is the thing that we are finding. The equation, again, is the one I just talked about, which is acceleration equals final velocity minus initial velocity divided by time. So once I figure out all of these different things, I can replace these variables with the actual values. So the 20 is final velocity. So see that VF, it matches right there. I'm going to plop that in. I'm going to take the 0 and I'm going to put it in here. And then I'm going to take the 5 for T and plop it in there. So that gives me this equation. So using my order of operations, remember I'm going to do 20 minus 0 first. So 20 minus 0 is 20, and then I'm going to divide it by 5 because my last step, remember, is to do the math. And 20 divided by 5 gives me 4 meters per second per second. All right, let's do one more example. So a landing plane touches the tarmac at 200 meters per second and slows down to a complete stop with an acceleration of negative 20 meters per second per second. Okay, how much time does the plane take to stop? Okay, so again, I need to identify my knowns and my unknowns. I know that the final velocity is 0 because the plane is slowing down. My acceleration, more specifically my deceleration, because we are slowing down, is negative 20 meters per second per second. And then that means what I'm starting with for my velocity is 200 meters per second. And what I'm looking for is time. But oh no, like, Miss Snow, you didn't really talk a lot about the time equation. Well, time can still equal velocity or final velocity minus initial velocity divided by acceleration. So we just rearranged the equation to solve for this. And so once I do that, I can plug it in. 0 minus 200 divided by negative 20. Remember, order of operations when we're doing the math, so we got to do the parentheses first. So 0 minus 200 meters per second is still negative 200, and I'm dividing by negative 20. So remember, when you multiply or divide a negative by a negative, it becomes a positive, which is time equals 10 seconds. Okay, because 200 divided by 20 is 10. And don't forget your units.